Hey, good afternoon, everybody. Welcome back to another webinar here with our UE system. Sorry, I'm losing my words already. This is not to a great start. But anyway, so today we are going to be talking electrical safety and inspections with ultrasound. So those of you that have been coming to our webinars the past 2 months or so, we've definitely covered a wide range of topics. A lot of them have not been ultrasound related, so we're excited today to get to dive in and talk about our bread and butter and what we're familiar with. So looking forward to that. So Doug Wagen is going to be presenting for us. Those of you that are kind of first timers to this, and those of you who aren't, you've heard this a few times, but we'll just continue to reiterate this point. But we want to be sure you guys know that we here at UE Systems are a resource. We're happy to do whatever we can to support you, even though we may not be able to be in your facilities and be face-to-face and do, in-person training and equipment orientations and things like that with you right now. We definitely want to do our best to make those things work, virtually. So if you need any software help or equipment help, or you just want to talk through your program or, help with procedures, anything like that, definitely reach out to us. We've got our awesome group of trainers who are obviously off the road, so they're available. All of our regional guys, they're all anxious to be able to spend time with you guys any way that they can. So definitely take us up on that. These webinars that we've been doing have been kind of part of a bigger program that we've been working in conjunction with our friends at Irraditio and RDI. So that continues this week. So you'll see that there's a website that Irraditio set up, help.irraditio.com. So in addition to all these webinars, which they do have those archived on that site, they've also gathered kind of an additional set of no-cost short-term project-based learning opportunities, videos, some e-learning modules. In addition to that, they've also made available some of their coaches for some no-cost coaching hours. So I think this is the last week that's going to be offered. So definitely jump on there and take advantage if you want to spend some time with some of their really awesome coaches that they've got. You definitely don't want to let that pass you by. So check out that website. I think they'll keep that site and some of these offerings available for a while. But anyway, just want to make sure you guys know about that. And then some housekeeping. So I am recording this just like we've recorded all the webinars that we've been doing. So we'll have it up on our YouTube channel. We'll have it on our website, and of course on that help.irraditio.com site that I just told you about. We definitely welcome questions, so you can type those into the questions box. I'll get those tossed to Doug as it makes sense if people are needing some clarification on things. And of course, we'll have a little bit of time at the end as well for some Q&A. And if we don't get to all the questions, we'll for sure follow up with you offline. We are going to try and make this a little bit more interactive than usual. So we've got some poll questions that we're going to be tossing to you guys throughout, just to kind of make sure everybody stays awake, right? And to learn a little bit more about you guys. So when those show up, we'd love for you to participate. And then, and this today more than ever, just ignore any, crazy noises or barking or yelling that you might hear. I do have my 10-year-old in charge of my 4-year-old and 2 dogs. So it could be interesting. So if I go silent all of a sudden, it's because I've muted myself, and Doug, you'll just take over. But we're all having fun, and we're getting through this best we can. So anyhow, with that, I am going to turn the screen over to you, Doug, and Doug, we'll let you take it away.
Thanks, Maureen, and good luck with that supervisory process of the 10 watching the 4. That does not sound like fun. Can you see my screen?
Yep, looks good.
All right. So good afternoon, everyone. It's great to be able to get back into the webinar scheme of things. I've sort of stepped away and haven't done one in quite a while. But this is actually one of my favorite topics when it comes to our products and when it comes to ultrasonics. Electrical safety and inspection is a huge topic inside of our industry. And this information that I'm going to share and this discussion that I'm going to start is it applies whether you're doing the electrical inspection of your electrical assets in your facility or whether you're contracting that out and having a service provider do it. So I'd encourage you guys to ask questions. And I'm going to get started just with a little bit about UE Systems for those of you who don't know us. We've been around forever, founded in 1973. We're located in the COVID hotspot of the country. We're 20 miles north of New York City, although things have certainly calmed down, especially in the suburbs. So we're really happy for that. We've got handheld and continuous monitoring solutions, and I'm going to talk a little bit about both of those today. Our handheld Ultra Probe series of instruments for doing electrical safety and inspections, and also some of our continuous monitoring options for electrical assets. Everything comes with a 5-year warranty. We're huge proponents of training. We've got our level 1 and level 2 ultrasound training. We're also, for a lot of people who have expressed interest in it, we've put together an online level 1 class that's an instructor-driven online course. So it's a scheduled course. It's not a take at your own pace. That's coming in the future. Who knows how long travel restrictions are going to last. So I give a hats off to our training department who put together a great level 1 course that, again, is instructor-led. So if you're interested in that, pop Maureen an email. We can get you some information about how it works and what we're able to do there. Once everybody's back to traveling, we have our 2.5-day and 4-day on-site implementation programs, which we love. Our guys love getting out in the field, working with you, and getting your program spun up. And then, of course, we've got Ultrasound World and Reliable Asset World. 2021, we can't wait for next year. That's going to be our 16th year doing the conference. It's just a great opportunity to learn. It's a great opportunity to network. Unfortunately, we weren't able to do it this year. We had to put it off to next year, but I'm sure everybody understands the conditions surrounding that. So how about you guys? You know a little bit about us. I'm going to let Maureen do a poll here, just to see who's using ultrasound in your facilities for any application. Doesn't have to be electrical.
There you go. And if you're having an issue voting, I think we've determined you need to have your screen minimized, I think, in order for it to work. So last week, I think it was working both ways. So anyway, just try both if it's not working, and hopefully you can get your vote in. So they're flying in here, Doug. We're up to about 60% of folks have responded, and of those, we got about 78% yes are using ultrasound, and 22% are not. So pretty good turnout of ultrasound folks. Yep.
Fantastic. I don't know how long these polls last, Maureen. You're gonna have to guide me through this. Should I move on?
Yeah, I closed it out, so you can.
Okay.
Screen's back to you.
Okay.
Yep.
Well, that's awesome. It's great to hear so many people are already using ultrasound. So let's look at some of the applications before I dig right into the electrical application. For those who aren't using ultrasound or aren't as familiar with this technology, heavily used for compressed air and compressed gas leak detection, a really easy, user-friendly tool that lets you go out and hunt down any kind of compressed gas leak or compressed air leak. And one of the unique things about the ultrasound products is that we can measure the size of that leak, and we can put a cost to that leak. And we can even, if you want to get it even more granular, we can even get to see what kind of greenhouse gas emissions that we can eliminate by repairing those leaks. So that's a great application. Probably many of you know we're heavily into mechanical applications and equipment reliability of rotating equipment. That's a great application for ultrasound. We can do that both with, handheld, route-based data collection, but we can also do that with continuous monitoring. We've got some really interesting, unique products for that. Heavily into condition-based lubrication. If you were on any of our webinars recently, we did one on condition-based lubrication and the use of the 401 grease caddy. Steam trap inspections, and of course, today we're going to jump right into the electrical side of things. Actually, my favorite application, and I think one of the ones that's kind of misunderstood And a lot of people look at electrical inspection the way it was 15 and 20 years ago, where you sort of needed to be a guru, where it was sort of magic to be able to go and identify problems and figure out how severe they were. Modern technology, the advent of being able to record sounds, and our newer ultra-probe instruments let us do a much better job and make it much more user-friendly and easy, to be effective at electrical inspection. And I think a lot of people think, having an insurance company come in once a year and do an infrared scan and sometimes an ultrasound scan is enough. I'm here to tell you it's not. And I think once we go through some of this, you'll see why. So for our ultrasound people out there, for our 78%, what application do you use it for? Maureen, another poll.
Here we go. And you can actually select more than one, I think, if I set that up right. If not, sorry.
You see, we're trying to be interactive here. We can't all be together in a big room. We can't be down at Ultrasound World in Clearwater Beach, asking questions and getting responses. I don't get to see everybody's smiling face when they're raising their hand at how many, great finds they had with their ultrasound program. So I guess this is the next best thing.
Yeah. All right. So we got a good group of folks who have responded, and it looks like 45% are doing bearings and lubrication. That's great. 26% are doing leak detection. We got about 20% doing electrical, and 10% on steam. So
awesome.
There you go.
Well, that's really cool that we've got some people doing electrical inspection. So I think I'm going to approach this today in sort of a why, what, how, when, where type of a deal. So I'm going to start out with why do we do electrical inspection? What's the motivation behind it? Why is it important? Okay. And I think we could all agree safety when it comes to any of our plant operations, any of our assets, and any reliability initiatives, safety is way at the top of the list. So a lot of doing electrical inspection with ultrasound is being driven by creating and fostering a safe work environment. And whether it's the people directly involved with inspecting things like switchgear and transformers, or whether it's just people working in production around that apparatus, safety is of the utmost importance. A lot of ultrasound inspection is also driven by insurance companies, and I'll talk about that in just a minute. There's also some recognized standards out there for employees that work around electrical equipment and are responsible for maintaining electrical assets in your plant. And then, of course, there's equipment reliability. It's another big, initiative inside of our facilities of why we want our electrical assets to run properly and run safely. So let's talk just a little bit about safety and probably one of the scariest things when we talk about ultrasonic inspection or infrared inspection around things like enclosed switchgear is the potential for an arc flash incident. As you can see up here, a report published in Industrial Safety and Hygiene News said there's on average about 30,000 arc flash incidents every year. Now, some are minor, some are major, but when we drill down into what those result in, 7,000 of those are burn injuries, 2,000 require hospitalization, which is to me just completely unacceptable, and 400 fatalities a year. That's somebody who dies every day because of an arc flash incident. That's what the stats say. So that's something that we need to address. One of the big reasons for ultrasonic inspection is going out and inspecting enclosed cabinets before they get opened to do an infrared inspection. So sort of a 1-2 application where ultrasound can certainly support your infrared programs. If you're doing infrared inspections of your enclosed switchgear, or if you have a contractor coming in to do it, it's a good idea to make sure they're doing an ultrasound inspection first, just to make sure that there's not some type of an incident or an anomaly going on inside of that cabinet before they open the door. Don't want to see anybody be part of these statistics. Yes.
For sure. And someone had a good question about these stats. Are those U.S. only, or is that worldwide?
That's U.S. only. That's U.S. only.
Okay, cool. Thanks.
So that's
well, not
yeah,
cool. That's
really,
a lot.
that's really
yeah.
scary. That's really scary that there's an arc flash fatality on average every day of the year. Okay. So anyway, I'm not trying to make this a scared straight presentation, but it is something I think warrants looking at. You can certainly go online and you can do your own research about arc flash. What is arc flash for those of you who don't know? Basically, it's a sudden release of electrical energy through the air. It causes usually an explosion, which creates a fireball that can be hotter than the surface of the sun. So it's really a dangerous situation. The extreme temperature caused the heating of surrounding air, so it also includes a lot of pressure. So it's literally an explosion. So even if you're completely PPE'd up and you're wearing the correct rating for arc flash, you could still get hurt by the blast itself throwing you across the room. And I've seen videos of it. I've read articles about it. It's really something that's it's kind of terrifying. So something to really think about. What can cause it? A lot of different things. I'm only listing a couple. One of the things that can cause it is opening a door or a panel. If there's something going on inside, some internal tracking going on, or some minor arcing going on, opening that door, opening that panel can cause an arc flash incident. So again, the importance of doing some type of a safety scan before you open a door to do work while it's energized, before you open a door to do infrared testing. Other things like dust, like dropping tools, accidentally making contact to fuses and things inside of switchgear can also be a major problem. Material failure, breakdown of insulation material, corrosion, even faulty installation. So there's a lot of things that can cause it. And then how bad is it? How severe is it? Really, that's how close is the worker to the hazard? Does the worker have the proper PPE on? The temperature, how fast does the arc flash last? In other words, is there time for the downstream circuit breaker to eliminate it? There's all kinds of different things that can determine how bad it is. But the easiest thing, in my opinion, is just don't let it happen in the first place. Insurance. Some of you may be aware of this. Most major industrial insurance providers, they will come out and work with you, sometimes even reducing what your premiums are if you're doing inspections. I just pulled this off of a website. This was from a major industrial insurance provider, and you can just see the list of things that they do for their customers. One of them is ultrasound inspections, along with infrared. So I think this is something that a lot of people don't realize that they can take advantage of. It's something that I'd recommend if you're doing inspections at your facility, or if you have an outside contractor coming in to do it or a service provider doing it. Talk to your insurance provider and see what kind of help they can be. If they can help you with inspections, if they can help you with reduced premiums. I don't know. I'm sure they're all different, but it certainly warrants taking a look at it. There's some standards out there. In this case, there's NFPA 70B. There's also a Canadian equivalent of that. And that really defines the electrical preventive maintenance program. It has ultrasound in two different sections. One of the sections about partial discharge and another about corona discharge. It mentions ultrasound by name. And it's really a recommended practice for any kind of electrical equipment maintenance. Okay, so that's one standard you should take a look at, get a copy of. Another standard is NFPA 70A. That doesn't specifically as much talk about preventive maintenance on electrical equipment. It talks about safety and working around electrical equipment. So again, standards are also driving a lot of the inspection work. When you read the standard, it comes right out and tells you, electrical apparatus, electrical assets should be inspected with ultrasound for partial discharge and corona. And lastly, certainly not leastly, is equipment reliability when you're doing electrical inspections. So I'd like everybody just to take a second. We're not going to do a poll here, but ask yourself these questions, okay? How important is the electrical distribution system in your facility? That's almost a silly question because it should be of critical importance to everybody's facility. I mean, it's of critical importance to your house. So, of course, your electrical distribution system is extremely important. And start looking at what are the consequences of an electrical failure. Obviously, safety is a huge one, not just for, someone getting injured doing an inspection of electrical gear, but what about, the workers nearby? What about the ancillary damage that can be done to other equipment when you've got some type of electrical failure, an explosion, or a fire? So besides the safety, what about the unplanned downtime? What about interrupted production? And what about damage to the actual assets? Especially if it's a large or expensive asset like a transformer, oftentimes they're not readily available. You don't have a lot of redundancy. So you really need to ask yourself those questions. What are the consequences? Have you looked at the criticality of your electrical assets? Have you done an actual criticality analysis? Extremely important. One of our past webinars was a couple weeks ago, Stop Acting Like a Teenager. If everything is critical, nothing is. Here's an opportunity where, somebody like Eurydicio, who we always partner with on these webinars, still doing their coaching this week, might be some questions you could ask them. Where can you go get more information on doing criticality analysis on your electrical assets? Have you looked at your electrical assets, and have you looked at how they've failed in the past or how they could fail? So almost, picking apart the asset and developing a failure mode-based strategy for doing these inspections based on the criticality, based on your failure mode-based strategy, should dictate how often you're testing the assets and which assets you're going to test. Okay, so think about that for just a second and ask yourself those questions. It's important. Part of any overall plant reliability program should certainly include your electrical distribution system in the plant. Here's a really good example of this is a large food manufacturing company. They have what I would consider a really mature, really world-class ultrasound program for all applications. One of the things they do is a monthly inspection of all their electrical assets in the plant. In this case, it was a couple of years ago, their main switchgear, just during a routine ultrasound inspection, they heard some anomalies. So they came in after they realized that there was something wrong, did a thermal inspection. They did confirm 2 out of 3 phases on the incoming bus work. So based on both those things, the plant was scheduled down anyway to replace that breaker. And while they were doing that, they actually identified that a bunch of bolts joining the buswork were also not properly torqued. So one of the things they did is, dealing with their electrical safety department and dealing with their maintenance department, they figured out continued operation, if they hadn't done that work, would definitely result in a plant-wide unscheduled downtime event. So this is actually coming from them. This wasn't coming from us. So it's just a good example of why it's important to maintain your electrical assets in your plant and do routine inspections. So let's get a little bit into the how. How do we do it? Ultrasound is an extremely easy, user-friendly technology. Separating good equipment from bad is initially just listening. You'll be able to identify, and I'll go through some sounds in a minute, of what good sounds like, what bad sounds like. So literally just testing and listening to your electrical assets is the first step. Second step, note any deviations, and whether that be an increase in overall sound level or decibels, or whether that be deviations when you analyze and review the sound files. Either one of those is going to help you determine what action to take and what to do next. How do we do it? What kind of tools do you need? As I mentioned early on, years and years ago, it was really difficult to do things like ascertain the difference between corona, tracking, and arcing. It was difficult to gauge severity on electrical faults. You really had to have a tremendous amount of experience. And I think I wouldn't discount having experience with electrical assets. Now it's still very important, but the technology's improved over the years. You know, any ultrasound detector is going to let you just go listen. But if you want to determine what the problem is and how severe it is, sound recording is something you really need. So just from a best practice standpoint, what we recommend for electrical inspection is at a minimum the UltraProbe 10,000 or the UltraProbe 15,000. Both have onboard sound recording. Both allow you to get the sound and look at it inside of a software package and look at a spectrum and a time waveform, both of which are critical for determining what the problem is and how severe it is. So again, how? Any kind of voltage, it really doesn't matter. You're going to scan in an airborne mode. It's very similar to leak detection, how you find electrical problems. You can be a little more focused because typically you're not scanning a very large area. You're going to know where the potential sounds are. We scan and listen anytime we've got, operating energized electrical components. And whether that be things like switchgear where we're listening internally, or whether we're out in a substation and we're listening to things like insulators, we're going to scan in an airborne mode and we're going to look for the loudest sound, just like we do with a leak. So what are we listening for? Well, we're not listening for a leak. We're listening for an ultrasonic signature caused by an electrical discharge. And there's typically, when we talk about our electrical assets, there's four things: corona, tracking, arcing, and in many cases, loose or vibrating components. And we want to be able to separate these, and we want to be able to gauge severity so we know what type of action to take. So, we also need to interpret the meaning of the sounds we hear based on what the operation of that equipment is. There's many pieces of equipment, for example, like a transformer, that are going to continuously hum. They're going to make noise. So what you need to understand is what good and bad sound like. So we're going to go through a couple of sound files here and talk about those different types of anomalies. Corona is just the ionization of air surrounding some electrical connection. It has to occur at greater than 1,000 volts. And one of the things that happens when corona is present and you add moisture and dirt to corona is nitric acid. So corona essentially is ionization. If we look at the difference between an infrared is basically looking for resistance, which causes heat. Ultrasound is looking for ionization. So that corona, while in many cases isn't damaging on its own, a lot of times you'll hear people say, oh, we've got nuisance corona in our substation. Yes, that is correct. Left unattended to, as that corona starts to escalate, as you add moisture and dirt to that and you produce nitric acid, you can start to break down some of the insulating material and some of the dielectrics used in that substation or on those insulators, and you're going to start to move into a situation where you've got a problem. Corona really doesn't produce a lot of significant heat. So I'm going to play a sound file for you guys. This is a typical sound of corona. if everybody could hear that okay. Maureen, sounded all right?
Yeah, it was a little faint, but just everybody bear with us. They do not make it easy on this system to play sound files. So we spent probably more time than we should have had to try and figure out how to do that. But we could hear it enough.
Okay. Hopefully the louder tracking and arcing will sound a little louder. Corona is a steady state, sort of a buzzing sound. And a couple of the things we want to look for when we look at our FFT of Corona, we're going to see some very distinct harmonics. Typically those harmonics, as you see here, are going to be at the carrier frequency. So they're going to be at 60 hertz in the US. If we went somewhere else, it'd be 50 hertz. But you're going to see these peaks all the way through that FFT at 50 hertz. What you're also going to see is a lot of frequency content in between those peaks. When we look at the time waveform, we're also going to see very little deviation in the amplitude of the sound, and we're going to see very uniform, even spacing of the anomaly of Corona, because you can actually look here, all these little incursions are the same distance apart. Okay, so keep that in the back of your head. That's what Corona sounds like, sort of a buzzing sound without a tremendous amount of deviation.
Hey, Doug, I don't know if when you did move your microphone there, if that kind of pulled anything out a little bit, but your audio got a little crackly just now.
Okay. How about now? Is that better?
No, there's something weird going on.
Huh. Hold on a second. Let me undo my headset and plug it back in.
Okay. Sorry, this is live TV, people. This is what's happening.
How about now? Any better?
It's still pretty crackly. Maybe it's just me. Okay, it could just be my phone then. People are saying
I think it's
sound fine. Okay, keep going then. It must be my ears.
I think it's you. So
okay.
Anyway,
Yikes.
The next thing we're going to talk about for a minute here is tracking. Tracking really is a low current pathway to ground across some type of insulating material. Tracking is sort of the scourge of electrical inspection. It's what we don't want to hear. We don't want to hear arcing either, but tracking is the beginning of all the problems typically. So we look at the sound of it, and I'm going to play this. Hopefully it'll come through. So hopefully everybody got to hear that. Some of the things we look at when we suspect tracking, when we look at an FFT and a time waveform of that sound, we may see some harmonics at the 60 cycles, but they usually quickly disappear. We also see just a lot of frequency content. But the easiest way to determine whether we've got a tracking issue is by looking at the time waveform. So when we look at our time waveform, we've got a great difference in amplitude. The amplitude, the sound level is getting louder and softer, louder and softer. And you probably could hear that when I played that wave file. The individual little pops are not in the same position. They're all random, the spacing. And then when they do happen, you can see some of them are real thin and they don't last very long. Some last a long time, like over here. So as we go through tracking, we start to see a big difference in the uniformity of that time waveform than what we saw when we looked at Corona. The next anomaly that we hope we never hear is arcing. Arcing really is a high current pathway to ground. It's usually across an insulator or some insulating material. We usually hear bursts of energy. It's very distinct, starts and stops. I'll play this for you. It should be easy to hear. So that's definitely not something that you want to hear when doing electrical inspections. You can see there's not really any distinctive harmonics at the 60 cycles. Sorry about that. And there's just a lot of uneven frequency content. But the real telling thing when we have arcing is when we look at the time waveform. There's a long distance between these discharges. Some of them last a long time, some are very short, but basically the non-uniformity of that time waveform and that very easy to recognize sound, those pops, those cracks, and those long bursts of energy are going to tell us that we're in trouble here, that we've got arcing. I don't have a sound file for the vibrating component, but it typically sounds very similar to Corona. What's going to help you discern whether you've got a loose fuse clip or a nameplate or something that's mechanically vibrating as far as not necessarily causing an electrical discharge is looking at the time waveform or the spectrum. In this case, looking at the spectrum shows us that we've got harmonics here at 30 hertz, which is half of the 60 hertz carrier wave, which means it's probably in this case a nameplate that's vibrating back and forth. So again, looking at just the sound, it'd be very difficult to tell the difference between Corona and vibrating components, or even a vibrating nameplate on the door of a piece of switchgear. When you pull in the spectrum analysis, when you pull in the time waveform analysis, it makes it very easy. So really, we look at three things when we try to gauge severity. How much deviation in the amplitude is there? So is the sound the same, or is it constantly changing, constantly getting louder and softer? The more the sound is changing, the more severe the problem is getting. How often are the discharges occurring, those pops, those cracks? The more they take place, the more severe it's getting. And when those discharges happen, and this is really where you have to look at the spectrums and the time waveforms. When those discharges occur, how long does each one last? As you could see from the difference between tracking and arcing, the amount of time that the discharge lasts goes dramatically up when we talk about arcing, because arcing is much more severe than tracking. So using not just the sound, but using the time waveform and the spectrum is the best way to gauge the severity of that electrical anomaly. Here's another example of tracking. You can see here the uneven spacing of the discharges. There appears to be no rhyme or reason to when they occur. Uneven height of them getting louder and softer. And there's a heavy amount of frequency content, which means there's a lot more discharge lasting a lot longer. So in this case, the tracking is much more severe than even in the previous case that we looked at back here. So the more the sound changes, the more often the discharges are, and the longer they last. The three things that are going to help us gauge severity. All right, a little more interaction for our ultrasound people out there. Where does permanent monitoring fit into your plans for critical assets? And this could be critical electrical assets. This could be critical pumps and motors, critical gearboxes. Have you thought about permanent monitoring? Is it something that you're involved in now, looking at in the future?
Sorry about my audio. Hopefully this is better. I moved to just using my phone and took my headset out.
Yeah, that's better.
Sorry about that.
No problem. I hope everybody can hear me okay.
Yeah, no, apparently you sound fine. I had a flurry of folks writing in that it was me. Yet again, I was the problem.
No, perfect. Perfect, because
yeah.
I certainly don't want to take the blame for it.
Right. All right, so we've got some good participation here. It sounds like you got about 19% are saying they've got kind of plans for that in the future. 29% are currently investigating. 22% are actually implementing as we speak. and 29% are in that kind of haven't considered category. So kind of
Awesome.
pretty even across the board there. Yep.
Okay. Well, thank you, everyone, for your participation. It's great to get some interaction, even though I'd rather hear you, answer the questions. It's not bad listening to Maureen give me percentages. So let's just take a second here and let's talk about some continuous monitoring. So if you've got critical electrical assets that you think you don't want to go out and inspect on a monthly, a quarterly, a semi-annually schedule, this solution, this Foresight system, is a permanent monitoring solution. We use 4 sensors. So if you have 4 different cabinets or 4 sections in one large cabinet, you can mount these airborne sensors, very similar to the airborne sensors used in a 15,000 or a 10,000. This Foresight box basically sits there and it listens all the time. It's never off. It's like a person standing in front of that switchgear, pulling the trigger 24/7, never sleeping. So the Foresight listens, and basically what it's listening for is an alarm. It's listening for it to exceed an alarm. So if that alarm is exceeded, as you see down here, the first thing it does is it stores a dB, it grabs a sound file, it sends it over to the computer, and it sends you a text and or an email identifying which one of the points has entered an alarm. You can get that on your tablet, on your phone. It'll give you which point it is. If the email, you can choose to get both, but in the email, you can actually pull in the sound file as well. So the system constantly is monitoring for an alarm condition, so you won't miss any type of an anomaly, any type of an event that takes place in that switchgear. So here's how it works. Again, a 4-sensor system. It's typically, the data is typically transferred via an Ethernet cable, but there's no reason you can't use a wireless router, but most of the systems in place now are using Ethernet. It sits there and listens. Again, if a point enters an alarm, it's going to send that to the computer. It's going to store a sound file in a dB. It's going to send an email and a text notifying whoever needs to be notified. And then we can also take information if we decide to archive it, and we can do everything we can do with our handheld tools. We can keep a historic permanent record of the history of what went on. We can chart it over time to see if there were deviations, and we can pull in basically either spectrum analysis data from an FFT or time waveform analysis. Again, a little closer picture of it. The continuous monitoring basically is going to sit there and it's going to wait for an alarm to happen. Again, with in this case, this tracking, we're able to take a closer look at it, the uneven discharges, the uneven band height, and heavy and frequency content. So in this case, that alarm was caused by tracking. We can take any of the information, whether it's from our handheld tools, whether it's from this continuous monitoring, and we can put it into a multimedia report, which can include a sound file. So now let's have some fun. We're going to listen to some sound files, actually recorded from an UltraProbe, and I'll tell you a little story behind each one. And these are actually real-world examples, problems that were found in the field, and we're going to let you guys guess what type of problem it is based on what we've learned and what we've talked about today. So number one, I'm going to play this sound file. I want you to take a look at the time waveform. In this case, it's a large transformer in a utility. I'll play that one more time. So I'll let Maureen do the poll on what we think that is. Is it Corona, tracking, or arcing?
All right, let's see how well you taught them. Votes are coming in. Let's get a few more in here before we... All right, so it looks like you got 27% think it's arcing, 35% believe it to be corona, and 38% heard tracking.
That was a tough one. It's especially tough because you can't hear the sound absolutely clearly when I'm putting my head an inch from my computer screen so that my earbuds are letting the speaker in my computer pick it up. But actually, for those who said tracking, congratulations. It did turn out to be tracking. This was in the Pacific Northwest at an actual power plant. And I personally was out with one of their maintenance techs, and we were actually doing a general demonstration. We were looking for bearing problems. We were looking for leaks. And we happened to go listen to a transformer. And I said, this sounds funny. So he listened to it. He agreed. We recorded the sound. We took the spectrum and the time waveform of it. And then later, during a scheduled outage, he actually emailed me this picture and said, hey, what we thought was tracking and what we thought was a problem was definitely a problem. That white oxidation on the coils was visual evidence that what we saw was tracking. So good job. Okay, I'm going to play you one more. Actually, I got two more, but I'm going to play this one. This is actually in Thailand, and this is at a utility in Thailand. It was a brand new plant that was being commissioned, hadn't even been operating, generating power yet. Okay, based on what we see in that time waveform, based on what we learned today, what do you think that one is? Open the polls, Maureen.
All right. All right, so this time, all right, so we've got about 44% believe arcing, 46% believe corona, and 9% believe tracking.
This is actually this is actually such severe tracking that we can classify it as arcing. So whoever said tracking or arcing, you're really both right. What was interesting about this was, as I said, a power plant that had not even been commissioned. They were just doing some run-up tests and putting power to a brand new substation. Those insulators that we were inspecting there, and you can see the gentleman with the hard hat on is Hayden Shum, our operations manager for Asia. I, of course, wasn't going to go in the substation, so I let him go in. And he tested that insulator. It was brand new. It was less than 2 weeks old. During the installation of the insulator, they had cracked it. And that was what that sound was. Left another week without doing anything, that would have arced over. It probably exploded. That's what the gentleman, the engineer we were dealing with, said. All right. Lastly, this is another transformer example. It's not a utility transformer. It's a smaller transformer at a facility. Again, doing just a routine ultrasound inspection of the outside of this facility. We picked up evidence of a problem. That transformer was 40 feet up on a utility pole, and we scanned it. The site contacted the utility company. The utility company confirmed the diagnosis and wanted to shut it down. Actually, they were only a day away from a scheduled shutdown. So they found that the fuse holders had separated, caused the problem. This was definitely a major downtime event if this transformer had gone down, because it was the main transformer supplying power to that facility. So let me play that for you and see what you think. That's a long one. It actually sounds like tap dancing, doesn't it? Open up the polls, Maureen.
All right. Sounded like my kids were tap dancing upstairs. I don't know what's going on, but the 10-year-old is not being able to contain the 4-year-old, which is probably a tall order for him anyway.
Oh, yeah.
Oh, Lord. We're almost done. All right, so looks like we got about 41% thinking arcing, 41% thinking corona, and poor tracking falling behind in the picks here at about 19%. So
okay, well,
actually,
this was tracking. You can see the time waveform here where you've got a pretty dramatic amplitude changes, but you really don't have. These bursts aren't lasting that long. You can actually hear them in the sound file. They're just clicking. Really, that was the most of that tracking was right across where those fuse holders had separated and caused the problem. So interesting one. I can see where people would think it was arcing. And again, I'm putting everybody sort of at an unfair advantage because it's really difficult to hear these. But that was definitely confirmed as tracking. So thank you for your participation. All right. So lastly, I like to say design for success. Do these things internally or demand that your service provider that you hire does it. Number one, follow safe best practices. Take a look at NFPA 70A and NFPA 70B. These are written by professionals. If you're going to work around electrical gear, if you're going to maintain your electrical assets in your plant, you should follow those best practices defined in those publications. Identify and evaluate the criticality of your electrical assets. Electrical problems are not something you're going to find every day, but typically when you do find it, it's a major issue. So evaluate the criticality, do a criticality analysis, and look at what the consequences of failure are going to be. Design a failure mode based strategy for your inspection program. Ultrasound is not the save all end all. As I mentioned earlier, if it's an ionization based problem, ultrasound is great. If it's a resistance based problem that you're looking for heat or a lack of heat, then infrared is your answer. There's other technologies that need to be employed, and the only way you can employ the right technology is to understand how those assets fail, is to know the failure modes and apply the right technology that can find the right failure mode. Refine your processes and procedures. Written procedures that focus on safety and are easy to follow are going to work best for you. There's all kinds of resources for you to go get, information on how to write, proper procedures. Document everything. Document your finds, take sound files, take pictures, get infrared images, document how long it takes to do the inspection, how long it takes to do the repair, document the parts needed for the repair. All of that is going to help you in the future for future inspections and to justify these types of programs. Review the results you get with everybody on the team. Share the success. You got to be a salesperson when it comes to any kind of reliability and maintenance. I never title it conclusions. When it comes to improving electrical maintenance and reliability, or really when it comes to improving any kind of maintenance, you're never done. There's always room for improvement. And that's all I got,
Awesome.
Maureen.
Great. Okay, so let's do like one or two questions here, and then I know we do need to wrap this up by 2. So real quick for everybody that was kind of asking that had a hard time hearing some of the sound files on our website uesystems.com, we've got a sound recording library where you can go and listen to all of these examples there. So definitely check that out. That was quite a few of the questions. So, hey, Doug, someone was curious, actually several people were kind of curious about when you were talking about the foresight and the sensors, the airborne sensors, how those get mounted and if they can be mounted externally or if they would need to be mounted inside the electrical gear.
Typically, they're mounted inside. Really, we don't have a specific mounting procedure for those. We're sort of relying on individual customers to figure out a mounting strategy, based on the fact that there's so many different sizes, configurations, types of switchgear. It'd be hard for us to come up with a be-all mounting system. I think it's going to have to be a custom one for each type of gear. But they're easy to mount. They're small. They're stainless steel. So it's some type of a clip or some type of a hanger is going to be fine to mount those. It's not. They don't need to be. It doesn't need to be that special. And as of right now, we're just starting through some pilot programs to experiment with mounting them on the outside of the switchgear. We don't know what kind of success we're going to get with that, but certainly we'll keep everybody posted on that one.
All right, awesome. Well, in the interest of time, I'm just going to take the screen back and just do a couple closing slides here. Again, we did record this, so for those of you who are asking, we'll have it up on our YouTube channel and website, hopefully later today, if not definitely by tomorrow. If you want me to send you that link specifically when I've got it up, just shoot me an email, and I've got my email on an upcoming slide here. But thank you so much, Doug. And again, I don't think we necessarily mentioned this. We have an online course specifically on electrical inspections that covers, of course, a lot of what Doug went over today, but at a much deeper level. So if that's of interest to you, you can learn more about that on our website. But if this is something you're going to pursue, I would highly recommend at least somebody on your team participating in that online class. We got some upcoming webinars. I don't know why I keep doing this. I keep deleting the Friday one. So tomorrow, James Kovacevic from Iridicio is going to be talking, kind of continuing his series he's been doing on job planning. So he's a huge wealth of knowledge on that. So if you're interested in that, and you haven't signed up for it yet, again, shoot me an email and I can get the registration link to you for that for tomorrow. Then next week we are going to do 2 UE Systems related webinars. So on Wednesday, for those of you that are using our software, we're going to do a DMS 6 overview and highlight the features and kind of do a quick kind of how-to on some of the main parts of DMS. So, normally we would be teaching a full day of software training tomorrow down in Clearwater Beach, and of course we're not there. So we're going to start doing some webinars on the software. So if that's something that's of interest, we'll have an invite out for that. And then on Thursday, we're going to talk energy conservation. So far in this kind of series of webinars, we've covered lubrication. We've covered, of course, the electrical today. We've done kind of an overview of all things ultrasound, but we do want to hit energy conservation, so leak detection, steam traps, valves, all that good stuff. So that's next week. So hopefully you guys can make some time to have lunch with us next week as well. And then here's our contact info. If you need anything at all, do not hesitate to reach out to me or anybody else on the team, and we'll for sure get you what you need. But we appreciate you guys spending some time with us today and for interacting on the polls and everything, and for bearing with us with some technical issues apparently on my end. And Doug, thanks for putting this together for us. And with that, I hope everybody has a great rest of the day, and we'll catch you guys later.